Problem, we're going to do a reduction of circuit and solve for I by dealing with we're going to deal with a series and parallel combination. In all our problems, first thing you have to do is solve for I. So what we're going to do is I leave this blank, not because what the problem is asking for, but I always leave problems generally relatively blank because you have to know by looking at a circuit what to do without anyone telling you what to do. Okay, so we're going to go ahead and start. In every problem that you start with the circuit reduction, right, we solve for current. Okay, and which current do we solve for? I. That's the current we're solving for. Where is this current we're solving for? Here. And we can call this I that's coming out here. Okay? Always. Okay? That's the rule of thumb. So now the question is, how do you reduce this circuit? Okay, well, you have to go through a series of steps. Okay, so the first step is obviously recognizing what we're looking for, right? So we have our cheat sheet out. In our cheat sheet, we look at, okay, so is our problem, I'm going to move this over, okay, is our problem, is what we're looking for a reduction to one circuit? Is it a series or a parallel? Okay, so if we look here, we have to go, we're looking at this direction, okay? In this direction, we look at, okay, does it look like this? Or is it looking like this or this? These two are the same. Well, it obviously looks like this. This is clearly a parallel circuit. Okay, so the first thing we're going to do, we're going to drop it to a parallel and use this equation. So let's just do that. Okay, so I'm right-handed. I'm going to move everything over. Okay, and I'm going to drop this to a parallel. Okay, RP is equal to R1, R2, R1 plus R2. Okay, so this is going to be, our parallel is going to equal to what? Our values are 10 and 5. I'm sorry, are 5 and 5 for R2 and R3. So that's 5 times 5, right? And this is a 5, by the way. I want to work on my handwriting. And that's 5 plus 5, right? Which is 25 over 10, which is 2.5. Okay, so now what we do is we go ahead and redraw the circuit again. I'm going to redraw it to make things simple. Okay, here. Okay, so RP is 2.5 ohms, which is equal to 2.5. So this and this are the same. Okay, so it's going to go this way. It's going to our solution is going to operate like in this manner. So now we look at, well, I need to get this down to 1 resistor. What do I do? Well, when we look at our circuit, okay, does it look like this? Absolutely not. Okay. This looks like that, right? So what does it look like? Well, it's in series, right? It's running across each other. So here I'm running across, right? They're in a row. So if these things are in a row, considering a series something is in a row, then what we do is we simply solve and we just add them. So we take this value here and we say R series is equal to R1 plus RP. Okay? So RS, 10 plus 5 is 15 ohms. I redraw the circuit again. RS. Okay, and here's my I. My RS value is equal to 15 ohms. Kind of get used to this format. So now we can solve for I. So V is equal to I over R. I is V over R. What's my V? My V is VS. My R is RS. That is what? 10. And my RS is 15. So my VS value here comes from the value up here, which is 10. My RS value here comes from the value here, which is 15. I is 10 over 15, which is 2/3. You know, we could just say this is 2/3, so this is 0.67 amps. Okay.